This is the Lessons Learned Report, presented by David Gathira, Christopher Abrahamson, Dennis Fabian, and Zachary Greenidge. The outline of this report is work performed during recovery, areas where the incident response team was effective, areas that need improvement, such as security controls and monitoring tools, how we can improve controls, how we can improve security awareness programs, operating system vulnerabilities that were leveraged, and managing patches and basic operating system security. The work performed during recovery included situational reports such as SITREP 1 and SITREP 2, and a software development matrix. These are the two SITREP reports, 1 and 2, and these situational reports were created in order to log security incidents at the conference. These two examples both have a level 1 priority and were violations of ISO 27000, the Country Privacy Act law. SITREP 1 looked at a ransomware attack on the HR department that affected 6 hosts, while SITREP 2 was also a ransomware attack, but this was on the entire conference network, and the scope has not yet been determined, and the hackers are demanding payment for the ransomware. Another thing performed during recovery was the software development matrix and evaluation. The waterfall model, the prototype model, agile software development, rapid application development, dynamic systems development, the spiral model, extreme programming, feature-driven development, joint application development, lean development, rational unified process, and Scrum development were all versions of software looked at. There are areas where the incident response team was effective. The team was effective while developing the situation reports and the matrix in order to log ongoing attacks and analyze methods to develop software to protect the conference from future attacks. These reports addressed ongoing threats, both of which were ransomware. The software development method analysis will allow the Chief Information Security Officer to develop a plan for programmers to prevent future attacks using a system that is both cost-effective and efficient. The incident response team quickly isolated the issue, had the necessary skills to recover the files without having to need to pay the ransom. They also had knowledge of various tools and technologies needed to avert a crisis caused by the ransomware, and they identified the scope of the malware and quickly closed the loops to avoid a recurrence. Areas that need improvement are substantial. Increased user IT security awareness, file monitoring and vulnerability management tools. Backup systems should be in place for contingency. Segmented network access to avoid spread of an attack should occur. Early threat detection systems, such as attachment scanning applications and web content filters, should be utilized, as well as installation of anti-malware and ransomware software. Devices should run frequent scheduled security scans, and secure software lifecycle development programs and training for all engineers in the lifecycle should be established. Source code should be obtained for all purchased software. Software and hardware should have a security handshake. Secure booting processes. Look for authentication codes and the system will not boot if codes are not recognized. Automation of manufacturing and testing regimes will help reduce the risk of human intervention. Track and trace programs establish provenance of all parts, components, and systems. Programs capture as-built component identity data for each assembly and automatically links the component identity data to sourcing information. Also, legacy support for end-of-life products and platforms will assure continued supply of authorized IP and parts. Security controls and monitoring tools are one area that needs increased improvement. Some of the principles include risk-based testing, identify assets, create an architecture overview, decompose applications, identify threats, document threats, and then rate the threats. Another area that needs to be improved is how we can improve controls. Authentication is the scheme where usernames and passwords are involved. Passphrases of at least 14 characters that are alphanumeric, including two-factor authentication, need to be used. Encryption, such as web traffic encryption, session encryption, and data encryption, also need to be used, including many standards. Physical disasters can also affect data centers, such as fires, wind damage, flooding, earthquakes, hurricanes, and these can all create barriers to defense against internal attacks. Additional control methods include limited sessions in quantity and duration, email security, network monitoring, configured firewalls, and antivirus. The security awareness programs also need to be improved. We need to address the personal life of employees. Some employees' lives range in divorce, financial hardship, new career paths, and being watchful of these events, we can prevent an attack. It also creates a culture of teamwork and makes employees feel important by recognizing their struggles and ultimately creating a positive work environment. Managing patches and operating system security is also important. The four major operating systems are Windows, Apple, Linux, and Unix, and each have security patches that are graded as recommended or required. Patches are also necessary for software, such as firewalls and anything else that exists on the network. Devices connected to the network need to download patches for all software and applications, such as Snapchat, which is an application that has been exploited recently. Thank you for listening to this presentation. This is for the Chief Information Security Officer, and hopefully our recommendations help the conference so these attacks do not occur again in the future.